Okay, so this is still concept 4, and now we're into section 4.2. And like I said, we're going to do this over 2 days. So we'll start it today, and then we'll pick up next time we return. So quick, we just did this. Someone give it to me in general, without looking at your notes, what vertex form of a quadratic is. Landon, you got it? Not times, it's raised to an exponent of 2. Yep. Plus k. Yep, there's no multiplication with that 2. It's raised to the exponent of 2. So again, that's vertex form of a quadratic. Well, in this 4.2 now we're going to get into standard form, which I touched on at the start of our notes in 4.1. Okay? So when looking at this equation in vertex form, what information can we gather from a quadratic in vertex form? Okay, so I have -3 times parentheses x plus 4 squared minus 5. What information can I gather from that? Blake. Okay, so what is the vertex?
-4.
Good. -4, -5, because remember standard form is x minus h. If this is x plus 4, it had to have been a -4. All right, so that's important. That's an easy one to mix up, is you write that as 4 -5. It's not 4 -5, it's -4 -5. Okay, is there any sort of translation? So we know our parent function is just that x squared, the parabola going through the origin, it opens up. Is there any sort of translation that's taking place with this one now that we've written in vertex form? Jack, what do you think? Translation is in a shift. So when we had y equals x squared, Jack, where's the vertex on y equals x squared? 0, 0. But what's our new vertex? Okay, so what's that do in terms of a shift? So my vertex was here at the origin, but now it's here at -4, -5. Now it's down here somewhere. So we can see that it actually shifted left 4 units and shifted down 5 units. Okay, every single point would make that shift. Every single point would go left 4, down 5. Okay, so we know there's a translation going on. What about, is there a reflection going on? In terms of the direction, is it opening up or opening down? How do we know it's opening down? Okay, it's opening down. Oops. Opening down because of the -3. More importantly, the negative out front tells it it's opening down. What about that actual 3 value? What's that tell us? Blake? It's narrower. So that 3 tells us that we're actually going to be narrower. So again, it's counterintuitive. If it's greater than 1, it makes it narrower. But how I think about it is it's jumping up in the y direction faster because I'm multiplying each point by 3. When I do like that half, it's getting wider because I'm going up half as much every single time. All right, so there's a lot of information we can pull if I give you something in vertex form. I can find the vertex, I can see there's a translation, I can see there's a reflection, I can see that the width is changed. Okay, so now into standard form. What again is standard form? Eli, you got it?
Y equals ax squared
ax squared
e plus bx
plus bx plus c. Okay, so now in this section, we're going to focus more on this standard form. The first section was all that vertex form stuff. Now we're going to work in standard form, and there's information that we can pull if it's already given to us in standard form. Or we can convert from standard form to vertex form and vice versa. So we can start moving stuff around a little bit to determine what exactly our final equation is going to look like based on the question. Okay. All right. Now we can look at, so again, standard form, y equals ax squared plus bx plus c. We can determine if it opens up or down by the exact same way we determined if in vertex form was up or down. All we're looking to see is it plus or minus a. Positive a tells me it's going to open up. Oh, that's not very good. Negative a tells me it's going to open down. Okay, so based on the sign of my a value, and that's always attached to the x squared, that's going to tell me if it opens up or if it opens down. The axis of symmetry. Okay, so what again is the relationship between axis of symmetry and the vertex? Sorry, what's my relationship between axis of symmetry and the vertex? So if I had some function look like this story, I know my vertex is here. Where is the axis of symmetry going to be? Okay, it's going to go right through it. Okay, it's a line that splits it right in half. Okay, so if I had some vertex that was here, say 4, 3, for example, I know that it had to went over here at 4. I don't want to do it as a point. I know it had to have crossed here at positive 4. So right away, my equation would be x equals 4. So if you know your vertex, the equation of the axis of symmetry is simply going to be the x coordinate. You could say x equals 4 in this case. Okay? So if we know where the axis of symmetry, or if we know the vertex, we can do the axis of symmetry. Vertex form, that makes it really easy. Standard form, it's not as easy. You can't just look at it and determine. So this is a formula that you need to know. If you are in standard form, you need to know that to find that axis of symmetry, your x equals, okay, it's going to be an equation, is negative b all over 2a. Box that in your notes, star it, do something. That is one that you need to know. If you are in standard form, to find the axis of symmetry, and this is also the x coordinates of the vertex, you need to know this. X equals negative b over 2a. And that b and a comes from your standard form. Remember, it's numbers. So all I have to do is put in my numbers. Okay, my b is this number, my a is this number, negative b over 2a. That tells me the x coordinate of my vertex, which is also the equation of the axis of symmetry. Okay, now to find coordinates of the vertex. Okay, this above it, the axis of symmetry, that gave me the x coordinate of the vertex. So x equals negative b over 2a gives the x coordinate. To find the y, you need to plug in the x. Okay, so for example, if I had some quadratic, y equals 2x squared minus 8x plus 7. So I say I had that quadratic. Okay, well, I can figure out, all right, from that one, let's figure out what the x coordinate is going to be. Well, the x coordinate is going to come from negative b over 2a Do not get mixed up with signs. So the equation is negative b over 2a. I have a negative 8. And so that's really a negative of negative 8 all over 2 times 2. So now it becomes positive 8 divided by 4 to get 2. So I know for this example, my x-coordinate is 2. My x-coordinate of the vertex. Now to determine y, I'm going to plug in that 2. So 2 times 2 squared. So this is 2 times 4. And so that's 8. Minus 16. So I'm at a negative 8. Plus 7. Negative 8 plus 7 tells me I'm going to be at negative 1. So y equals negative 1. So for this example, I would say then that my vertex coordinates are going to be my x, which was 2, my y is negative 1. You will have to do this over and over and over. So ask me questions if this doesn't make sense. Landon.
How did you get the 8?
So that's your a and your b value. Okay? So this is in standard form, 2x squared minus 8x plus 7. So my a is 2, my b is negative 8. Okay? So I put it in here, so be careful now because it's a negative of b. So a negative of negative 8. 2 times my a value, my a was 2. The 8, what you said, or the a? The 8, okay, right here. So this is just an example. So I just, this 2x squared minus 8x plus 7, I just pulled that out of thin air. That wasn't anything, that's just an example problem. Okay, so if given this equation, y equals 2x squared minus 8x plus 7, if given that equation, I can find the coordinates of the vertex based on this negative b over 2a. Like I said, you will do this over and over and over. So ask me questions right now of what doesn't make sense with this. All right? Okay. Now the last thing, it already popped up there, but the y-intercept. In standard form, y equals ax squared plus bx plus c. This right here is the y-intercept. This last piece, every single time, is the y-intercept. So if it's in standard form, you can just look at that last term and you say, yep, that is my y-intercept. That's where it's going to cross. So like this one, 2x squared minus 8x plus 7, I know it's going to cross the y-axis at a positive 7. Okay. Let's do one real quick, and then this will be it. All right, what can we find from y equals x squared plus 2x plus 3? And we're eventually going to graph this one. Looking at it, do I know if this is going to open up or down? Up. And how do I know it's going to open up? From the x? X or x squared? Ah, right here. The sign on this is a positive sign, and so this one is going to open up because it's positive. If it were negative x squared, again, it's only the sign on the x squared term. You don't have to look at the signs on any other ones, just the sign on the x squared term. So I know it's going to open up. What about the axis of symmetry? Okay, so here's where that equation is coming in. The axis of symmetry comes from this negative b over 2a. We have to use that. Okay. What is my b value in this one? 2. But we're going to write it as negative 2 because it's negative b, so it's negative 2 in the numerator. All divided by 2 times what? 1. That's the a value. So again, this is ax squared plus bx plus c. All right, so as long as you know this negative b over 2a, you simply just have to look, okay, my b is this, my a is this, I can plug it in, and so I have negative 2 divided by 2, which is negative 1. So that tells me my vertex is going to be some negative 1 coordinate, but also x equaling negative 1 is the equation of the axis of symmetry. I know I'm going to have a vertical line at x equaling negative 1. Okay, now coordinates of the vertex, I know I have negative 1. I need to figure out what that y value is. How do I determine that y value again if I know my x is negative 1? Morgan, what do you say? How do I figure out the y value? Do I have anything that says like y equals? Yeah, so the very beginning right here, standard form, to find y, I just have to put in my x, which is what I know. So I can use my original standard form. It's going to be y is going to be negative 1 squared plus 2 times negative 1 plus 3. So this becomes 1 minus 2 plus 3. 1 minus 2 would be a negative 1. Negative 1 plus 3 would end up with a positive 2. And then what is the y-intercept? Looking at that equation in standard form, what's the y-intercept? Or Blake? 3. Okay, right here, this is the y-intercept. Okay, so if I were to graph now all this information, I want to graph x squared plus 2x plus 3. I know my vertex is here at negative 1 and 2. So I know I have that point right there. I know my y-intercept is also 3. I know my axis of symmetry was going right here through negative 1. So I can say negative 2, 3, I know will be another point. And then it's just going to be opening up. And so this one, I'd be okay if you did just sketch it. And so there's my equation, x squared plus 2x plus 3. Graph my vertex, graph my y-intercept. I want to see both of those at the minimum, and then reflect at least 1 point over. The more points, the better. But show me that you know where that axis of symmetry is to create the reflection, opening in the correct direction. There's your parabola. Jake.
A minute ago, you told us about some.
So if I ask you to do if I ask you to graph something, and I give you a grid, or I'm specific saying graph this parabola, I want to see 5 points. Okay? If I say something like sketch the parabola or use the vertex and the y-intercept to draw the parabola, I'm okay with, as long as you give me those main points and which way it opens, I'm good with that. So I will be specific, and I might even go as far as say, this is the one I want 5 points. So 4.1, good question. 4.1, I do want you to give me 5 points when you're graphing those for practice. Sam. Go where? Okay, so we know our y-intercept is here at 3. Okay, so the y-intercept means where it's going to cross the x-axis. So it might be hard to see, but this is 3 on the y-axis. Okay, so I know my y-intercept is 3. So all I have to do is go on my y-axis, plot 3 as a point. Because what that's saying, if I put 0 in here and 0 in here, these go away, all I'm left with is 3 anyway. Okay, and then I reflected that point across the axis of symmetry because the axis of symmetry goes right through the vertex. Good question. Any other ones? Okay, so that's it for this section. Page 206, 11 through 23, the odds, and number 16. please graph 17 through 23 odds on graph paper. So I have a bunch of graph paper over here by the cleaning supplies. So make sure you're doing those on graph paper. I want you to be specific on those ones.